everybody. This is PCI's Juice Applications webinar. I'm here with Wes Alexander from Membrane Specialist, and we're happy here to talk to you about juice applications using PCI technology. So here's the content. I'll be talking briefly about PCI, and then Wes is going to talk about what Membrane Specialist does. And then we're going to jump into juice applications, very specifically talking about our K19 product line and our Aiden product line. And then from there, we'll talk briefly about some spiral wound technology that we use for juice concentration. And then from there, we're going to go into a couple of case studies. So
yeah, very excited to introduce the case series.
Excellent, thanks, Les. Thanks. Yeah, I'm looking forward to it too. So PCI is our manufacturing facility is in Poznan, Poland. We have a couple of sales offices in the UK and one here in the United States. PCI has been making membranes for over 50 years, and we're in various different marketplaces such as water and wastewater, food and beverage, pharmaceutical, chemical, pulp and paper, and we're able to use a whole filtration spectrum. So we make membranes, everything from MF, UF, NF, and RO. The PCI is part of the much larger group called Filtration Group. There are 29 other companies that belong to Filtration Group. When we break these 29 companies down into two different marketplaces, life sciences and special technologies, as well as process technologies. As you see, there's quite a few different other filtration companies here. Some of them that you might recognize being in food and beverage will be Global Filters, Porex, as well as Waco. And the Filtration Group strategy is making the world a safer, healthier, and more productive world. So Wes, why don't you talk a little bit about what Membrane Specialist does?
Membrane Specialists, we're a company, we specialize in process design. We're an OEM for membrane plants and development. We've been around since 2009, but our roots actually come out of PCI. So our owners, we have two, they are former PCI employees who moved to the US in the 90s to set up shop here and start to develop business interests for the PCI product line. And over the course of time, the PCI product made some changes. And so Membrane Specialist was basically born out of those changes. And what we have been able to do is establish and build and work to evolve PCI's footprint in different markets and applications. And what we do as a company is we specialize in membrane filtration. We try to take an unbiased approach to be able to develop the best options for the application for the client. And that includes a number of services, range of services, including pilots. We do a lot of pilot and testing in our facility, and we do that all the way up to large-scale commercial plants. We work in the territories of North and South America, and we work within industries such as fruit juice, like we'll be talking today. We also work in pharmaceutical, water and wastewater, mining industries, minerals, extractions, other types of industries, fine chemicals and pulp and paper, for example. Today, what I've done is I've put together just an intro on what our mission and values are, and our vision. We try to be experts in developing and engineering innovative membrane separation processes, but we really focus specifically on enabling our customers to be leaders in their field. And that manifests into a lot of different great conversations and activities for us as a team. And some of those examples you can see here. That top right system was a plant we built a few years back, but that's actually a very specialized process for some coconut extractions. The bottom left is a more traditional fruit juice clarification system. And then in the middle there, you have another fruit juice plant, which I can't go into too much, but it's a fully automated system that has lots of interesting concepts around it. I thought just giving you an idea and visually what we do, what types of things we get involved in.
How many
Very
pilot
happy
units
here.
do you have? You guys have a whole different slew of pilot units and different capabilities?
Yeah, we have about I'd say we have three tiers of pilot units. We have lab scale, that's benchtop. We have medium scale, that's process that can do anything from RO to UF, particularly tailored to the PCI product as well. And we also have large demonstration units. We probably have a handful, 5 large demonstration units, about 12 middle range, and about 5 lab scale units. And they're pretty much either rented out on site or they're being used in our lab constantly.
Awesome. Yeah. All right. Excellent. All right. So let's move into juice applications. I'm going to talk briefly about the typical juice processing process flow diagram. So we all start with, some types of fruit. When the fruit arrives to the facility, in most cases, it has some kind of debris or dirt on it. So one of the first things you'd want to do is wash the fruit. And then from there, you want to press the juice out of the fruit itself. And then from there, some type of enzyme treatment to remove pectin. And this is where we will see the first type of filtration system in this process. And this is used for clarification. And we either use the K19 or A19 product. And so once you clarify the juice, you can go 2 different ways. One could be down to pasteurization, or in some cases, you can even use sterile filtration, integrity tested membrane filters here, and then you could pretty much bottle it from there. Or if you want to make some type of concentrate, you take the clarified juice and you go directly to an evaporator. Or in some cases, what some juice companies do is they use a spiral wound RO system to remove the water from the juice. And what they do is they will pre-concentrate it before we get to the evaporator. So in some cases, as your company is growing and your evaporator is getting too small, you don't need to always just go out and buy a bigger evaporator. What you can do here is buy a spiral wound system to basically, provide higher concentration solids to the evaporator, therefore making it more efficient. So right, yeah, here's the area we'll be talking about right now is clarification. And so the 2 different products that we use for clarification will be our A product line and our K19 product line. The K19 is brand new to PCI. It was just launched just a couple of months ago. The K19 product line uses our tubular membranes. It's a completely plug and play module. They come in various different lengths, and you replace the whole module out on the system when the membranes need to be replaced. And then we also have the A product line where the membrane core can be replaced, and the stainless steel shroud that is in, or the stainless steel housing remains in place. And then from there, it's a much easier and cheaper change out for these membranes. And we make them in A19, which means there are 19 tubes, as well as an A37, where there are 37 tubes.
Yeah, and some people think of them as the 3-inch or the 4-inch housing as well.
That's more common name is 3 and 4 inch. Yeah.
Yeah,
It might be 4.3.
yeah, something like that.
All right, so PCI tubular membrane. So this is what inside these modules. So this is really where the separation is occurring. And the picture on the right really tells a great story where PCI membranes, we use a staggered weld on our tape when we make the membranes. And by doing so, we're able to have higher pressures than what our competitors have as far as operating pressures. So because of the staggered weld, we're able to get to 7 bar pressure, where a lot of the other competitors out there are only able to go to 5 bar. And so, that extra pressure, you're able to get to higher concentrations and therefore get more value out of your process. And then again, you can see how the staggered weld is by these breaks. I think a picture is worth 1,000 words, and this one right here really proves it. So you can see how this one just seems much stronger than a wall built this way. If I have a house, I definitely want the bottom picture then compared to the top picture.
Yeah, and that extra wrapping, I mean, the other huge benefit it gives you is just longevity, just the durability of the product really outshines the other weld type. And that has huge implications for operations and downtime and efficiency of your production and operations as well.
So yeah, so we make various different molecular weight cutoffs for the different juices out there. For dark color juices, we like to use more of an open filter at 0.2, which is a micro filter at that point. And the main reason there is because you want some of that color to go through to the final product. And in some cases, if we use something too tight, in some cases we can actually remove the color and making the product, you know, less appealing. So yeah, so which is more valuable. Also, when we use a more open media for the 0.2, we get better flux characteristics. So we're able to basically, you know, filter more quicker. So K19 products. So this is what the main part of the presentation is about. So this is a brand new product from PCI. It's pretty much a whole module. It's a see-through housing shroud, so you can actually see the tubes inside it. Right now we have the K19, which is a direct replacement. Where if you're using a competitor's module right now, this module comes in 10 and 12 feet long, and it's direct replacement. So there's no modification to the system needed at all whatsoever. So in some cases, we have some people that actually use our A product line. The A product line we'll talk about in a little while, but there you're able to remove the core. So here with the K19, you replace the whole module. They come in various different molecular weight cutoffs. The membrane material themselves in this module is PVDF. The housing material is also BPA free, which is also relatively easy. Humans, you know, don't like BPA. It's not good for us. So, you know, it's better not to have BPA in the housing at all whatsoever. And these modules are CFR, FDA CFR for the States, as well as EU regulated for Europe. And they also have a kosher certification as well. So here's a nice picture of what what a bunch of filters will look like in series, in parallel on a K19 module.
So some of the benefits you get in that design is with competitor type systems, you know, you can get into issues of some flexibility and some flexible. There's a little bit of a tolerance give for other types of systems. So what this new product can do is it can help with fit up, as Bob said. You know, it's just like a direct replacement, and there's advantages to the K19 product that definitely can support a new alternative to some of those folks who have other types of similar cassettes on their skids.
All right, next slide. So this slide just shows you different types of you know, the 10 and 12 inch 10 and 12 foot lengths that we make. It also talks about, you know, the size for inlet outlet connections, as well as the membrane surface area, as well as how much these modules weigh when empty. And then once again, these are the different molecular weight cutoffs that we manufacture each one of these in. So 0.2, 450, all the way up to 20. So just to get a understanding of how much surface area is in one of these modules. Obviously, when we're talking about filtration, you know, surface area, membrane area is king. That makes, you know, the more surface area you have, generally the faster things go, and hopefully the better things go as well. So the advantages of the K19. So one of the first things we talked about was the pressure. Most of the systems out there are only capable of going to 5 bar, 5.2 bar. Ours is capable of going up to 7 bar, and by doing so, you're able to get, you know, more throughput through your filters. Basically, you're able to run the system about 35% operational pressure increase from a 5.2 bar to a 7 bar.
Yeah, that's a really big advantage in terms of juice production and your ability to take things down to a concentration factor. Most juice folks out there are doing batch concentration, top batch concentration, and having that extra little bit of pressure gives you quite a bit more ability, as well as, you know, again, preventing membrane breakages, which equal downtime and loss of product. So it's a very important distinction.
Yeah, so because of the higher pressure rate, we're also then able to increase yield. You know, going from 90 to 95% recovery is you know, it's quite something else, and therefore all that extra juice, that's extra money for your facility and for your employees. So, just by being able to go to that and enhanced operating pressure gives you basically more recovery. And then also it's cost effective, right? So when looking at other types of technology, like the A series we're going to talk about, you need to do some retrofit into the system. You might need to, you're buying stainless steel vessels, so it's a little bit more CapEx front. So you pay more on the front than you do at the back end. Well, the K19, due to the fact that this is just a direct replacement, there's really no modifications needed to your system. And therefore, once you install a K19, you can see instant savings right away. And then also we talk about reduced downtime and labor cost. They say that it takes approximately 90 minutes if a tube does break during production. You're down for quite a while. Almost over an hour and a half. I think in some cases it could be even longer than that, depending on what element actually broke inside your process, right? If it's one in the kind of the middle and hard to get to, it's going to take you a little bit more time to change it out compared to say one on the front or side of the machine where it's easy to reach.
Yeah, sometimes it can be difficult to know even where that breakage can happen because those are all common. They're run to a common manifold, so you can see all sorts of different types of breakages that can bleed into other modules, and you've got to hunt it down if you're not watching it like a hawk. And those challenges can be really hard on a system and also an operational culture, because you're sort of thinking, well, when's the shoe going to drop? When's the emergency going to happen? And that can be challenging. So with a product like this, and those folks who already have the A series, and they already understand the benefits of having more robust membranes. They already have the advantages, and now all they're concerned with is the core replacement. So there's this efficiency of form that those folks who already have the A series are seeing and enjoying and are looking at getting that advantage and have put that upfront investment in, but have now been seeing rewards year after year after year. And this next product really it allows for an easier transition to those who haven't taken that step, but then gives them those benefits that the more robust membrane offers. And it also gives them the benefits of just the quality that the PCI product has with it. It's a very well made product that has a very rigorous QC process.
Yeah, so your point about having a clear shroud, right? We have multiple modules in series, right? It's hard to tell which tube is actually broken, right? But due to the fact that we have that, almost clear shroud or see-through shroud, right? It's a benefit of being able to see which one of those modules failed at the point.
Yeah, and I think that's been really the appeal in the States for the clear shroud, is that they like to be able to see those breakages. And what we've seen sort of anecdotally is that is a part of operations. So part of operations is you should expect to see maybe once a week for some folks, maybe once every other week, some breakage. And then there's a standard operating procedure for replacing those membranes. While with the PCI product line, traditionally you have to flip that narrative. And now we don't talk about membrane breakages. But what we do have with the clear shroud advantage is the confidence that those membranes are in good shape, a little bit extra oversight. And, as you said, you really have that extra 35% increase in operational pressure available to you, which gives you just a great amount of flexibility in the system. And you also have the extra temperature tolerance. So there's twofold factor there, and that extra temperature tolerance really comes into play when you look at cleanability. And again, both of those factors come back to membrane life. The longer we can have the membranes sustained and perform well, the better return on investment you're going to get. So we're trying to chase that. We're trying to understand what that looks like. And it's not just about throwing fruit juice into the system, it's what fruit juice. And it's what season and it's what year. Because what we find is that the the makeup of proteins in these fruits changes, and they're being engineered and modified and designed in all sorts of ways. And there's different challenges with different seasons, with droughts and with different yields. So all these factors play into how you run the system and how you manage it. And if you're able to put in a more robust product, if you're able to put something in that has more of a tolerance to these variabilities, you're going to see better results, more consistent, and you'll be able to really adjust the operating culture to say, hey, we have to stay ahead of this. We're no longer just trying to fight fires. Now we're managing and controlling our process. And it's a big jump.
Great, that was excellent, Wes. Thanks. All right, so I guess we'll talk about the last point on this slide, right? The advantages is the customization and flow control. And so basically these systems are, in some cases, can be pretty large, 80, 90 something modules. And the first couple of, I guess, modules will see a lot more pressure than the back modules do. So what we do is we're able to use some different types of permeate gasketing to make sure that pressure is more consistent throughout the system. And that makes the system just run more efficiently and lasting longer. And so that's just another thing that we can do with this K19 product line, is by manipulating the permeate gaskets, we're able to, change how the performance of the machine actually operates. And to do so, we're just trying to improve system efficiency and make the system last for longer, so we make more money. So going from the K now to the A19. So the A19 product line has been around for some time. It's the A19, it's just like the K19 has 19 tubes inside of it. It's also PVDF material. It's also used a polyester for the potting material of it all. And again, it comes in 1, 2, 3, 5 different types of molecular weight cutoffs. Flow is from inside to out. But with here, when the membranes finally need to be changed out, you don't change out the whole module. What you do is just change out the core. And by doing so, over time, you save yourself a lot of money by just replacing out the core without changing out any other plastic or stainless, right? Well, the issue, one of the problems as well with the A19 is that you had a system already, you needed to modify it. And when you needed to modify it, just, that takes some time and cost, as well as the cost for the stainless steel shrouds are pretty expensive. However, once you make the conversion and you do install the stainless steel vessels, the housings, membrane replacement is pennies compared to what it would be for changing out complete modules.
It really depends on, I'm just sorry, Bob, jumping.
No, go.
It really depends on, what your system looks like. And for some, it's clear that the K series is the way you should go. For others, there's a lot of different manufacturers out there that have designed systems differently over the years. And in my experience, we've seen systems that have been still in operation 20 years in service and just kicking along, and their design is totally different. So it really makes a difference to look at your system, understand what you have, and then make a decision from there based on what the cost breakouts look like. And in some cases, this is a great product. In other cases, the K series is going to be what you're going to want to look for. What I would say, which is interesting, is this product, the A series, they used to not have, the locking pin arrangement, and they used to not have the whole thing. Actually, it was one potted stainless steel shroud, just like the K series, and you would discard it just like the K series and chuck in the the stainless potted, and it was obviously not cost effective.
Right.
And they went
waste stainless steel is not very efficient.
So a lot of energy went into this recorable concept, and one of the things that they were think about for this recorable concept is that it's definitely less wastage. You're not wasting the PVDF. You're not wasting the the housing and everything, the polysulfone housing and whatnot. So it's definitely a good product, and for those who know how to use it, it's great. But there's now just that other option to you.
Yeah. So for people already using or that did change over to A product lines, just stay with the A, right? Because it's going to be cheaper to change out just the cores instead of the complete K19 module. If you haven't done anything yet, right, maybe the best option right now might be going with the K19, or you can look at to see if it's justified. Like, I guess how many times you change the membranes out per year or per, how often, right, will justify the ROI. Would it make sense to go with the A or with the K? Do you spend that capital
Yeah,
in the A, or do you kind of just say, kind of the medium with the K
that's a
product line?
that's exactly right. Some juices, you're looking at one season and that's it. Some juices you're looking at 3 seasons. Some juices you're looking at more. Um, and we've seen everything and in between. So all those factors play a role into what your decision should be.
So, I know Membrane Specialist actually has went out and retrofitted a few systems out there, right, with the A technology. So tell me a little bit more about what happens when you retrofit one of these. If someone's using, say, a standard throwaway module, and now you want to go in there with the A, what type of, adjustments or modifications to the system did you guys make?
So there's 4 points of contact for these modules. You have the inlet and you have the outlet, and then you have a permeate and a drain side, which are basically two permeate ports. And those ports are sometimes hard piped, meaning that there's a rigid pipe to all ports. And when you're trying to retrofit a a module where there's rigidity on all ports, typically the tolerances aren't there for you to just put in like this stainless steel module. You'll have to look at modifying the system so that you can get a little bit of flexibility. Now, the thing that's nice about these systems is that usually the fixed rigid connections of the feed or retentate, which are the potted ends on the right side there, um, you can match that up and that's fine. And then what you leave floating free is the permeate offtakes, in which case you can then get them fit. But that means typically you'll have to add hoses to each connection, and you might need to add like a tri-clamped barb or something like that. And you just need to build in that flexibility. So that's some of the stuff you're mentioning, Bob, and it's a great point. If you're looking at that and you're having to make a lot of modifications in that way, and in some cases, in many cases, it's better to put something that can plug and play and give you that flexibility for what you need to do in your operations.
But it doesn't sound like where it's too difficult when you have to retrofit it. It doesn't sound like where you're cutting a frame apart or you're changing doing a massive rebuild on the system. It's just trying to get the connections to match up, which,
Yeah, that's right. You're just trying to get the connections matched up. Sometimes customers want to do things like they want to sample per module to be able to do like a turbidity test on each module. So they'll want to add things instead of retrofitting just the bare minimum bar. They'll raise the bar on their system design to try to get some more flexibilities. Um, or the easier one typically is to do a turbidity test per row, add sample valves, per manifold. That's the common to the permeate side. Um, so there's different things to talk about, but you're right. It's not incredibly difficult. It's just stuff to think about. It's not like we could just send you a crate of these modules and you could just put them in
yeah.
without any thought. Yeah, and I'd
Okay.
say the same thing for the K series. It's maybe less thought, but we should still be thinking about what needs to happen for that all to work out.
Absolutely. Great point, Wes. Thanks a lot. All right. And yeah. So then and again, another one of these product sheets just to show you some of the membrane surface area. And again, with different molecular weight cutoffs that we have. And then the A19 comes with 1 inch and also 3/4 inch permeate and drain points, which Wes mentioned before, I believe, as well as a hold up volume. Some cases, sometimes juice can be valuable, so you don't want to have a whole large hold up volume. So we just provide information like that on this particular slide. And before we mentioned the larger A37, so this is just pretty much like the A19, but this has 37 modules. Again, it comes in 5 different molecular weight cutoffs. The 12.5 or the half-inch, internal diameter of the tubes, and that internal diameter, we didn't mention it before, but one of the advantages of having the tube that is so wide, or the lumen so big, is that in some cases you don't need pre-filtration. When we deal with systems that have much smaller lumens, 0.8 millimeters, something really small, you want to make sure you don't block those holes up. So you need to do some type of pre-filtration because of the fact that these modules, the larger lumens, the thicker tubes, the tube diameter, you can handle much higher solids and higher viscosities as well. Once
Yeah,
again,
typically we look at packing density. So the more membrane area you can get into a cassette, the better you are typically, But there's reasons to go with the 4-inch or the 3-inch or the A37 or the A19. And they have a lot to do with, what you're expecting, how you're expecting to operate the system, the frequency, what types of operations you're doing. And so there are two products that remain on the market because they both serve different purposes, and they have different, there's an advantage to both of them for sure.
yeah, excellent. Thanks. Yeah, so pretty much this is like an A19, but a larger A37. You see on the bottom picture over here, you see all these set screws. That's what Wes was mentioning before. These actually keep the core in place. So we're able to
Yeah, thanks,
smooth,
Bob.
put the core back in, set these set screws, and yeah, you're pretty much off and running. And then the A37 data sheet as well. Just some good information on that. All right, so we're going back to the juice process flow diagram, and now we're going to talk briefly about spiral ROs. PCI supplies ROs, spiral wound sanitary ROs for various different applications, a lot in dairy processing. So we do a lot with WPC, whey protein concentrates, and WPI, whey protein isolates. However, they're used in many various other industries as well as soy sauce and even in juice. So we do have the capability of providing and building spiral wound systems for juice concentration. And one of the main reasons why we would use spiral wound, say over tubular, is because of what was mentioned before, is the packing density. We're able to get a lot of filtration area in a very small area. So by doing so, you have a very smaller footprint, and therefore you don't need something as large. Less housings equals less less capital investment. So yeah, so spiral wounds are used in various applications, especially in juice concentration. These are widely used. So we actually make them in MFUF and RO. So depending on what you're trying to do, we have all those different molecular weight cutoffs, as well as all the different spaces available.
And this is this is a relatively new new product line for you as well, right, Bob?
Absolutely, yeah. So we recently just launched our spiral wound technology here in the States, probably around 5 or 6 months, 6 months ago, pretty much when I first started. And we've really been focusing and working with the dairy industry because, that's where most of this concentration is happening. If you've ever been inside a dairy facility that's making whey protein powder, they have rows and rows and rooms and
Yeah.
miles of spiral wound technology. So that was one of the first places that we kind of focused on. But now talking about juice, I thought it'd be silly not to mention that PCI has spiral wound technology available as well, because a lot of juice facilities out there do use spiral wound for concentration, which makes sense.
So this is a good opportunity to get your clarification step and your concentration step from one source, and we can normalize that supply chain. And as Bob mentioned, because you're already going through the clarification step, you've removed all those solids. Now you're looking at bricks concentration, and you need RO for that. You need it to be a sanitary element, and there's various different strategies to run the system. Again, depending on what juices and what you're doing, or if you are going to be doing concentration, it's a great way to make efficient your evaporator as well. So Yeah, all good points, Bob.
And then you guys, Wes, do a lot with water and wastewater using spiral mounts as well, right? As far as I understand, you guys do some work with spirals for water and wastewater, right?
Yeah, again, going back to that packing density comment that you made,
Yeah,
for wastewaters, sometimes those volumes are just really high, and the consistency of those feeds are, they don't there's something they're not as challenging as say that fruit juice clarification step. So, we would be looking at something like a spiral system. But it really just again depends on what you're throwing at it and what it's trying to do. But I think what we're seeing these days is a big interest in water reclamation around these plants, looking at ways to to bring back some of these wastes that wasn't in the culture before, it wasn't in the appetite before. So it'd be very interesting to see how membranes continue to play a more significant role in these plants.
absolutely. And I know in the dairy industry, a lot of these dairies now want to be zero dependent on water because there's so much water in milk, and when they're filtering it out, they can use that water for other parts of the processes within a dairy plant. So yeah, spiral mounts have their place. They're pretty, decent, pretty inexpensive membrane as far as membranes go. They do have some downsides. The cleanability of them all, they're very difficult to clean. They are polymeric, so they can't go to higher temperatures for cleaning. And yeah, there's but there's a lot of upsides as well. All right. Anyway, moving forward, we're going to talk now about a couple of case studies. I'll do the first one, and then Wes will do the next one. So we were working with this one particular juice customer that was basically filtering dark juices, and they were using our UF membranes, and they were not satisfied with the color throughput on the membrane. So we did some work with them, and we were able to basically change the UF membranes to our A19 LMO2. So basically, it's a microfiltration, a 0.2 filter, and therefore the color was actually able to go through the membrane, which the customer was liking. However, we were able to remove what they wanted to, and because we went from UF to NF, we were able to increase the retention by 30%. So in some cases, everyone thinks, hey, going tight is always better. In some cases, it's not. So this is one area where, hey, you know what, we're able to do the same exact thing the customer wants to, but with more and more open membrane. Therefore, what we're getting higher throughputs, and the customers, happy with the color they have on the turbidity on the other side. When you're dealing with dark juices, it's you're always dealing with polyphenols and acidity and pectins. Pectins can always have issues when you're dealing with a membrane system. So, using these tubular membranes, especially on the A19, is the way to go. Yeah, I'm not sure it was actually an orange juice, even though we have a picture of an orange juice over there. It was definitely a different juice than orange juice. But
Yeah.
what's his point before, when we're looking at the solution, we're not just looking about, okay, you're dealing with a juice. What kind of juice are you making? How much of it? How fast do you want to process it? All the other various juices that you're making as well, because that system can be used for, obviously, pretty much oil production, not just one particular part of the process or part of your production.
Yeah, and if you're looking at, say, citric juices, lime, lemon, even orange, you're worried about things like limonene, and limonene will deteriorate the pot of polysulfone, and PCI has an option to do a non-polysulfone, which can greatly enhance the life of that membrane cassette. So there's lots of good options out there for how to handle these juices. And I think one of the things that I really like about the PCI product is that you guys are always thinking, what modifications can we make to this membrane or the way this is made so that it's more efficient, it works better in the field, has longevity? How do we overcome some of these challenges? And instead of saying, well, here's the product and the product is the product, it's a constant evolution to improve the process.
The juices, right? The fruits that they get are seasonal. So every juice is going to be different every year. depending on the weather itself and various different, things out there. So yeah, so it's never like you're going to be using Concord juice. It's always going to be different from year to year to year. So like you
And
said,
that's actually by design, because I think that, and I'm not a fruit juice expert, but I know that the tastes of the consumer changes. So they play with the acidities to make things more acidic or to have a certain flavor, texture, or profile. There's a couple aspects in terms of spoilage to look at, and membranes can really enhance um, the durability of the juice itself, as well as really target the aesthetics that you want out of that juice. So the color and the richness, and you don't lose as much of those flavors that you might find are degraded in similar processes, like high temperature processes.
oh yeah, when you pasteurize juice, yeah, definitely gives it a little bit of a different flavor to it, right?
Mhm.
All right, so Wes, I think we have one more slide, and then we're going to go into the Q&A. Emily, hopefully we had a couple of questions come up during the conversation. So with that, Wes, nice slide.
Yeah, I thought about what we should talk about today, and what I wanted to bring up was just something that's a little bit more unique. I know, Bob, you talked about sort of the modifications of putting in the other membrane type and being able to do things that were not as is a little bit counterintuitive with the color retention. And you also mentioned that it's all about turbidity. It's all about keeping that spec in line with what the end customer who is going to be or the end product that you're going to be putting on the shelf, and what that spec needs to be. And for this particular case, we have a customer who has a high it's a high demand. They actually run quite a few different juices and products through their clarification system, and they had been testing a bunch of different membranes based on what they were running. And that's pretty often the case when you have a company that is running a dark juice, and then they'll have a light juice run, and then they'll have something in between. And what they wanted to know was, could they mix and match membranes to get more life out of those membranes that they had on hand without losing them? And specifically, they were trying to run the FP20s, 200,000 molecular weight cutoff, and they had a bunch of LPA 450s, 450,000 molecular weight cutoff. We were able to do some modeling. We were able to work with them and put in these membranes in a specific location to allow them to use those membranes, but not reduce the quality beyond the turbidity expectations. And you can think of this kind of like the ceramic membranes now these days. They're coming out with gradient type membranes where they're actually different pore sizes throughout the length of the membrane. And you can look at the impact of that pore size change. And we were able to see with the flow path and the concentration gradient that you could mix and match these membranes, and things would be okay for you. And so we were able to implement this a few years back again, and it was not a challenge to the customer. And along those lines, just to really harp on membrane life, because it's just so important. There's other strategies that you can look at, including cycling the membrane. So rather than keeping a membrane fixed in its position, where it's always, say, at the front of the line of, sometimes they run 16, sometimes in series, sometimes they run less, sometimes more. But you instead of putting that membrane at the very front end, right at the pump outlet there, moving that membrane to another spot and putting a new membrane right at the outlet seasonally, and cycling that way can really also help extend membrane life. So lots of different and good strategies around the management of your system. So yeah, I thought that'd be a good thing to put in people's minds around how these membranes can be run, how these systems can be run, and you know, a lot of different technologies do not do well with just putting in and plugging and playing different filtration types in the same system, but this is a very robust product.
Excellent. Well, Wes, excellent. Thank you very much. We kind of nailed that one. It's 11:45, but now it's 11:46. So
I think
45 minutes.
I took you 1 minute on. Sorry about that.
That was perfect, Wes. No problem. No problem. So excellent case study. Thank you very much. And Emily.
Thank you, both of you. I do have some question here for you regarding the K19 series, as it's a new product. So I have a couple of questions for you. First question is, can we install any PCI tubes into a K19 module?
So the answer will be we have 5 right now that you can choose from. So I put those up on the screen before. So it's dependent on what type of juice we want to do. So the dark juices we have 0.2, and we go all the way to the I don't remember the other ones, Wes. You know the lucky weights.
Yeah, you have the
20 KD,
450,
100, 200, and 450, and 0.2. So those are the 1, 2, 3, 4, 5 that we have right now. But if there's a particular tube that you're working with that you would want in the K19 module, we could probably do that for you. You know, as we manufacture them in Poland. So if there is the 12.5 millimeter tube that works specifically well on one of your particular juices, there's a very good chance we'd be able to install that tube inside a K19 module.
Yeah, and I'd add to that point. You know, oftentimes there's the proof is in the pudding, as they say, and with these types of systems, you know, you may not want to take the risk on changing out the entire system. For some folks, what they'll do is they will just get a selection to try for the first season to see how the performance looks, and that is definitely an option as well that we can work through.
Sounds good.
What do we do? They have 96 elements. They will put 12 in or 7 in and see how they perform compared to the rest.
Yeah, that's exactly right. So we'll say, well, this is where typically what we do is we say this is where the most impact is to the membrane, which is usually the front of the line, as I mentioned before. And what they'll do is they'll put in 4 or 8 or sometimes 16, but put them in not in a single pathway, but at each start of each pathway. And obviously you can't just put any membrane in. You'd want to match up what you're doing so that the expectation would be commensurate with what your system performance was. You're trying to get sort of like a like for like comparison, but really it's just about confidence. It's about seeing that product in the stack work, and then you start to see the advantages, and pretty soon, you know, there's a new option to you, and there's that flexibility as well.
So Emily, just to confirm, right, we make it 20 KD, 100 KD, 200 KD, 450 KD, and 0.2 micron.
It's nice to know. Thank you both.
Yeah, that's correct. Yeah.
Then my second question regarding K19 is K19 module, can we do back flush for the K19 module?
So the answer to that is no. These tubular membranes are not designed to be back flushed or back pulsed. I do know there are some technologies out there, like Wes mentioned before, like ceramics. I know we can back flush ceramics, and you back flush some hollow fiber type of technologies, but with tubular and even with spiral mount technologies, it's not recommended to be back flushed. They're not designed to do so.
Yeah, for these products, the tube is, you know, you saw in the picture, it's a plastic pot, and then there's tubes going through it. Those tubes are not reinforced at all. There's another module that that PCI has the B1 series where the tubes are actually jacketed with a stainless support tube. In this case, they're not. So they're engineered for the ability to handle pressure on the inside of the tube out. So they're able to handle pressure from inside out, but they're not designed to handle pressure from outside in. So if your pressure on your shroud exceeds something like, I think it's like 1.5 bar, 2 bar over your inside tube, inside of the tube, then you could see a collapse of the membrane. And there's different there's ways you might operate the system that could actually provoke that outcome in, beyond back flushing. So when you're looking at, say, 16 in series, every module you go through, you're going to lose that pressure. And so at the end of the run, that's where your lowest pressure is going to be. What we try to do is we try to maintain, above around 20 PSI at the outlet to ensure that we don't have that membrane collapse.
Okay, thanks, Wes. Thanks, Bob. Then the third question is regarding the core of the module. Can the core be removed from the K19 module?
Yeah, so no, that's no, the whole module for the K19 replaced. And if you want to just replace the core, that will be our A series. Wes also mentioned our B series. So one thing I did not mention, which I guess I should have, PCI is the only one in the world that I know of that makes tubular membranes and NF and RO. And so when you go to the RO spectrum of the filtration range, that's where we use our B1 housing, where the tubes are fed into a tube nest. And the reason why they get put inside these B1 tube nest modules is because of that higher pressure. You can't go to 60 bar in a plastic shroud, so we need to go to higher pressures. So hence we use stainless steel. But that's for a whole different another conversation, I guess, Wes. Which
that's another webinar.
Yeah, that's the next webinar. I actually had pretty fun doing this with you, Wes. It was fantastic. Emily, I assume that was the last question, or do you have anything else? Any other questions?
For the questions, we are all good. Thank you both for your answers.
Thank you.
Great. Yeah.
And thank you for setting all this up. I hope everyone out there got some good knowledge out of this. I'm excited to see what K19 could do out there in the juice world.
Yeah, absolutely. If you have any questions or requests to talk more into details, please contact us and we will share with you what we know.
Awesome. Well,
Yeah,
Wes,
perfect.
thanks a lot. It was a pleasure, seeing you, working with you as always. Emily, thank you very much. And I'm going to sign off. Thank you very much.
Thank you, everybody. Have a good day.
Thanks,
Bye.
everybody.